Linear relations and functions. So we'll be working with linear relations and functions here for a few days. This should really be a review from your Algebra 1 days, but that's why it's good. It's a review. And we start off by the domain and the range of a function. Now the domain is the value of x. We might characterize them most often as the value of the x values. It is the independent variable, and the range are most often characterized as our y values or the dependent variable. And we're asked here to start to state the domain and the range of each relation, and we got a couple that we're going to look at. So let's look first at the domain. Well, let's see. The domain then is going to be equal to, and I'm just looking at my values of x from this graph here on the coordinate plane. So let's see. So I'm moving along the horizontal axis. 1, 2, 3. All right, so I see we got an x value of -3. And I've got a value here at -2. And we got a value here at -1 when x is 0. 1. And 1, 2, 3. And 1, 2, 3, 4. Well, there you go. We've defined our domain. Now, what about our range? I'm looking at values corresponding to the vertical axis. So let's see, going down here, got 1, 2, that's -3. 1, 2, -2. And that's all the negatives I got. Okay, right there where y is 1, got a couple. When y is 2, +2, got a couple. And 1, 2, 3, 4 when y is 4. All right, so then we're asked to determine whether this is a function, whether these relations are a function. Well, one of the ways, and particularly on a coordinate plane, that I can determine whether a relation is a function is by using the vertical line test. And if I were to draw vertical lines through every point here, then if it is a function, that vertical line should only go through one of the points on the graph. So let's see, if I put a vertical line here, well, that's just going through one. But when I put a vertical line right through here, when x is -2, y can equal either +1 or -2. And if it is a function, there is only going to be, for any value in the domain, there is only going to be one value, one y value for each x value. And so therefore, in this case, this is not a function. I got two values of y corresponding to a single value of x. When x is -2, y could either be +1 or -2, and therefore it is not a function. Now let's look at whether we got it. And since it's not a function, we don't have to answer the other questions about whether it's 1-to-1, onto, both, or neither. But let's look at another one that's in the form of a mapping. All right, well, stating the domain and the range in this case is pretty easy. We just go right down the list. So the domain is going to be equal to -3, -2, -1, 0, and 1. And the range is going to be equal to 0, 2, 4, 6, 8. Domain, the values of x. Range, the values of y. Domain and x values represent the independent variable. The range, the values of y, represent the dependent variable. Now, is this a function? So as we look at this, all right, this -3, that corresponds to 0. -2 in the domain corresponds to +2 in the range. -1 corresponds to 6 in the range. 0 corresponds to 4 in the range. And +1 corresponds to 6 in the range. And don't get confused. Even though there's two values of x that correspond to one value of y, that doesn't disqualify it as being a function. In fact, what we really see here is that for each value of x, there is only one value of y linked to that value of x. And so we can say, at least here, that yes, this is a function. So it is a function. Now, is it one-to-one? Is it on-to, both, or neither? Well, let's see. If it was one-to-one, there would be only one value in the range corresponding to any number of x values. But we see here that this 6, when y is 6, or when the range is 6, x could equal either -1 or 1. And so that means it's not one-to-one. Now, on-to would say that each element of the range corresponds to an element of the domain. But I've got one element of the range, 8, that's not corresponding to any element of the domain. So it's not on-to either. And since it's not one-to-one and it's not on-to, then the answer here is it's neither. It's not either one-to-one or on-to. When it comes to evaluating the one-to-one and the on-to functions, and whether it's both one-to-one and on-to, it takes a little practice. Sometimes I get confused on it myself. But in this case, I can see that it is neither.